turn the mic over to Dale Turner.
Dale Turner.
And he's got his presentation. You are retired from TI.
TI Raytheon.
TI Raytheon.
You know, slaves have to be sold. They used to be at TI.
I know the feeling on Raytheon myself.
He got let go.
See if I can get this thing to work. Okay. A little bit about me. I started out as a ham in the Canal Zone in 1960 as K5RWK, and then when I came back to the States with my dad was in the military, W4 NOU, and then when I picked up my ham call again, W5 NOU. So sometimes I stumble over my own words. I got started on this antenna idea when my wife said, "Get rid of this. I don't care what you do with it, just make it go away." So I put it on the back fence, and the trash people wouldn't take it. So I did the worst thing I could possibly do, which was cut it off, because you need the boom length for a long periodic. And when I did that, and I should have cut off the spreaders and saved them, and I didn't. I just chopped it off. Yeah, I'll do something with it. And I kept it around, and then I found out you only had 400 megahertz repeater coming online. I said, well, you know, maybe it would be a good idea to save some of the parts. And meanwhile, whispering in my ear, get rid of that thing. Get rid of that thing. Well, it didn't get rid of, so I decided I'd just model it first. One we slipped, and the goal was 6 elements. Well, the reason there's 6 elements is because there's 6 plastic parts on that antenna. There's 6 little plastic parts, and you need those to isolate the elements from the beam, from the main boom. So I said, well, I could make a 6th element. You know, if I find another antenna, maybe, and this next time I'll save the boom, I'll make more elements. But 6 elements, 400 to 500 megahertz, with a good clean VSWR, good clean signal. I would like 10 dB a gain. I'll take what I get. VSWR less than 1.5 over the band with 15 dB return loss. That's mediocre, pretty good, and easy to build with hand tools. I don't want to have to build something, you know, go pay for machinists and build something really exotic. So, go to the next one. And that, of course, is the dead one. That's what it looked like. And so I modeled it, and you'll notice this is what I have right now. You notice the little boom gizmo right there on the end, and all the spacing. This was my best guess at what that thing is. Go to the next one, please. And so when the model came back, you'll notice the VSWR looks pretty sad. I went from 100 to 450 just to see what it would do. And I figured out real quick it wasn't going to do much. So I said, well, let's see what else it does. And that was the old antenna. That was the VSWR, really sick. And you'll notice you've only got one little spot anywhere near a match. And the pattern was really sad. At 5 dB on the outer ring, and then you had like 2 dB, 2.5 dB front to back, so it just no way. So I said, well, I'll try a different design. These guys have a design out there posted on the internet. They're in, I think, Czechoslovakia or someplace. And it looked pretty much like what I have, but it uses different element lengths. And so we'll just try it, see what that looked like. And this is what this guy suggested. If anybody wants to go out and look at it, there is a link for it. And that's the spacing. This is all in centimeters, so I had to convert it all to inches and all like that. And this again is in centimeters, so I had to convert it. And this is what they claim that they would get. And so I said, well, we'll see. They're using a gamma match and a single element. We'll see. So I modeled, took their dimensions, that's their dimensions, and this is what I got. Not so hot. I mean, it's not bad, but it's still not quite what I'm looking for.
So this is a Yagi.
This is a Yagi. I just thought, well, yeah, maybe I could make a Yagi out of it. This is what the Smith chart looks like, and as you can see, it's not too hot. And this is the pattern, which was, don't think so. So it's time to look for another approach. Let's look and see what an LPDA would do, law of periodic dipole array. This is from the ARRL antenna book, and this is right out of the antenna book, and this explains the ratio of the supposed vertex, the alpha, the tau, and then it gives you links. Basically you're putting elements on a circle, a series of circles is basically what that is. So for each circle, that's the length and the distance from the vertex, and that's how the math works in the computer. Thanks. Then again, this is right out of this is the boom length versus gain versus their calculations, and they say, okay, this is for a sparse antenna, this is for heavily filled, and the difference, you can notice there's a whole lot more, and because there's a whole lot more elements, your Smith chart pattern begins to tighten up. And so you get more elements you can put on it over a wide frequency range, you get a much cleaner VSWR and a much nicer pattern. If your VSWR goes to heck, then what you wind up with is a pattern to go along right with it. They just fall apart. So this is the antenna. It's online. You can just call up their web page. You can put in your elements and see what you get. And if you don't like what you get, you can put in some more and just keep doing it until you get what you want. Well, I said I had a 39-inch boom, and I had 400 to 500, and I hit the button, and when I hit the button, I got 6 elements. And so that worked out really nice. Actually, the first time I got like 15 elements or something like that. Some crazy number, but I just kept reducing the boom length until I got the right number. I'm not spare you with all the experimentation. But I just kept reducing the boom length until I got the right number. You'll notice that I tightened up the frequencies a little bit. The literature says if you go outside the bandwidth, your in-band performance is much better. So if you build it for slightly outside your band, then when you go to the bands you really are interested in, you have much tighter, much better results. And you can see I've got 6 rods, and these are all the spacings that I need. So I built it up in the appropriate way, and use what is called wide spacing. I call this wide spacing. And that's basically, I said, okay, I'm going to use the beam, I'm going to use the plastic parts that I have, I'm going to go ahead with the phasing, but I'm just going to try and bring this down to just like I have on my model here. I'm going to basically use that spacing for my 300 ohms. This is somewhere in the neighborhood of 400 to 600 ohms when it's really wide like that. And let's just see what we get. I mean, it's not costing us anything, and we'll just try it. And that's what we got. Not so hot. Okay down here, but at this end, not so good. And you'll notice that you've got a nice spread on your VSWR pattern. It's tight right here, so you could adjust some phasing, and you could get one end. One end's pretty close to the center of the chart, but the rest of it, not so good. And the pattern, we're getting 7.3 on this. This is the low end. I'm getting 7.3 gain with a 20 dB front to back. And this one's 7.09 with 21 dB front to back. And this is 6.6 at 21 gain. So it's, you know, it's okay, but it's not really, we can do better. So let's go ahead on. So let's use a different design program and see what we get. And again, this is found at that location. You can download it onto your PC. You can play with it right there. Just put your parameters in, hit the go button, and see what you get. And you can tweak them until you get what you want. And this is, I'm sorry that their background is blue, which says they wrote it in C. Okay, they wrote it in C, so it makes it really tough to see. But that's 420 to 450, and I got 6 elements, and here's the dimensions for the 6 elements over here, and there's the spacing for the 6 elements. Okay. So there it is in all its glory, and you'll notice that the purple lines are current, lines of current. And you'll notice the current distribution is more towards the small end of the scale. This is the low frequency, this is the high frequency. And so you'll notice that you've got more current at the high frequencies than you do at the low. And again, not so good VSWR. And you'll notice that this is just completely wacko. But we get, at the low end, we get 6.3 dB gain. We get front to back is 16. And 6.07, 15 front to back. And 5.8 with a 14. So we need a new approach. We'll remove the stubs and move the elements closer together. So we'll see what we get when we do that. So here, when I say stubs, what I'm talking about is you'll notice that right there is the antenna line, and there's a little space right in here. Can everybody see that? There's a little space right in here, and I'm calling that a stub. Okay, turns out that's probably capacitive. So it doesn't do much, and it doesn't show much on the chart. But when you do look at it, and when you say, okay, we'll pretend it's not there, and you can actually get rid of that aluminum wire and put in some real copper wire, and pretend that it's much closer together, and that's what I've done here. And I've come up with by doing some measurements what I think it ought to look like, and that's basically what that is. And then these are the phase switchers in the middle, but they're closer together. The outside is somewhere around 2, 2.25, 2.5. The inside, these measurements are somewhere around an inch. They're an inch spacing. So it's roughly an improvement. But the elements are basically the same. So let's see what that looks like. Whoa, Mr. Telephone. We got a much better VSWR performance. You'll notice that it's coming right in close to it's coming closer to the center, and it's not spread. You'll notice that the others were kind of spread out. You'll notice how tight that is. And now we have 7 dB on the outer ring, and we have 25 dB front to back. We have 6.8 with 23 dB front to back, and 6.2, 21 dB. Well, that's better. That's better. And here are the actual dimensions. This is what I was hoping I would clean this up, but I didn't. But this is what comes out of NEC, okay? The Easy NEC, which is the analysis program, and it tells you where what all your dimensions are. That's how close it is to the center. And that's the far end of it. And then that's the diameter of the tubing that I'm using, about 3. So I actually ran it at 3, and then I ran it at 3.75, which is standard tubing size. And there's, for all intents and purposes, it's slightly more capacitive, but it's so small that it's don't even worry about it. So you can actually make these elements out of tubing, 375 tubing, and it would be just fine. And this is more of the same, more of the same, more of the same, and that's it. Questions?
How does it work?
I have no idea.
Theoretically, it's perfect.
Theoretically, it looks good. The next step is going to be, barring any physical parts or problems on my part, I'm going to get the drill out. I'm going to start taking this thing apart, and I'm going to start working at it. If I get it done by mid-year, that'll be great.
How are you going to change the engine from 350 to 350?
The elements really don't care that much. I mean, if you were going for squeeze every bit of it, you could go through the calculations and actually calculate that, what it should be. But from the what I've seen, close counts. You just don't want those antenna elements spread, some over here and some over here. You want to bring them close together, and it's about 350. You know, I can run the models again if you really want to know exactly what that is. I'll be glad to share the information I've got if anybody's interested. I think when we put it together, the biggest problem we're going to have with this is because it's open wire, you're going to have to take open wire feed that into your shack, and you're going to have to cut that feed long and then use a marquee. Anybody ever heard of marquee? They're a microwave house. They make a ballon that's from like 200 kilohertz to 1.7 gigahertz. It'll handle 50 watts. Bad news, $65. So you're going to have to get a ballon for it. Other than that, it ought to fly. That's what they said, the Wright brothers said, it ought to fly.
Dave, if you give us an email copy of the presentation, I'll post it on the website. That way, for a $20 bill,
I want change.
I'll return it.
Sure.
That's good.
Sure.
That way we don't have to make notes of those
Yeah.
links.
Sure.
Got video.
I'm good. Thank you.